So today we're going to talk about calibration of the finished module. So I'm back into the Mutable instruments documentation, and we've seen this before. So it says that in a DIY situation, the most direct way of calibrating the module is to initialize the structure, storing the calibration data to the correct values deduced by measurement. And then it says modify settings in it to include the following lines. Well, we've seen this and we've expanded that out to cover all 6 channels. So let's go and have a look at that again just for a moment. So as seen before, this is my settings.hh file, which is flushed that out for every single channel for the DAC offset and scale and the ADC offset and scale. So that is our set point for how the module will run when we flash this into its memory. Let's go to the next bit. So it looks like what we need to do is to calibrate this is actually to apply some voltages to it and then record what happens to the outputs. So instead of going through the toil of doing that myself, I did a quick search on the web, and I came to this resource called Forestcaver on the Githubs. Now within here, this person has kindly added some process and methodology of how to do this. So if we go down to, if I can find my mouse, MI Stages stuff, click on there, you'll see a whole bunch of files here. And you see the Stages Calibration XLS. We'll have a look at that in a moment. It's got calibration notes.txt, and that's the factory test CC. We'll talk about that in a little while. And the settings.cc is the file we just looked at. So let's move on to have a look at the Stages Calibration XLS. So here is the spreadsheet which we use to calculate the new offset and scale values. So let's have a look at this top bit. So that's for the DAC, and the cells highlighted in green are the actual figures that I used to calibrate this module. So what we do is put the module into factory test mode for the DAC side of the microcontroller, and we subject the input, CV input, to -1 volts to begin with for each of the 6 channels. So when I did my calibration, I subjected the first channel to -1 volt, and the actual reading I got out of it using a fairly accurate multimeter was 0.935. Then we need to continue on and do all 6 channels. The next test is to subject each input to 2 volts, and we look at the output for each of the 6 channels and we record that. Now the person who put this table together has done some calculations, and right at the end there it calculates these figures. So we've got the scale and the offset for each of the 6 channels for the DAC. So we'll come back to those in a little while. The second stage is to put the module in the factory test mode for the DAC. So we did the, for the ADC. So we do the DAC first, and then reflash the microcontroller to go into factory test mode for the ADC, and then we do a similar thing. we subject the input to -1 volts, and we record what the output gives. And then we subject it to 2 volts, and then we record what the outputs are. And then the spreadsheet will calculate the scale and offset for each channel. So how do we put the microcontroller in factory test mode? What we need to do is have a look at that factorytest.cc file. Let's have a look at that now. So here I am in factory test code, and the author of this has put his initials there. He's put these statements in. So if we see that hash and if 0, DAC calibration. So what we need to do is change that if 0 to if 1, and then reflash the controller with the code changed as I've just said, and then we can go in and do the calibration of the DAC, so we can fill in the relevant cells in that table and get the relevant changes to the offset and scale. Once we've done that bit, scrolling up a little bit, what we do is change that back to 0, come down and change that if 0 to 1. So in essence we're going to turn that one off and turn this part of the routine on, and it says there AD cell calibration. So again, we turn that to if 1, flash the controller, and then we do the second part of the calibration and fill the table out, or the spreadsheet should I say, and acquire the scale and offsets for the ADC. So to reiterate, here's my settings.hh file, and this was the initiating data the first time I flashed the microcontroller. As you can see, there are all the values there as per the Mutable Instruments website that we've shown you earlier. So after we've done our calibration work and we've used the spreadsheet to calculate the offset and scale for the DAC and ADC for all 6 channels, I've actually taken the figures out of the spreadsheet and put them in here. As shown. So if we go to the top one, you've got a value there of 27255. And that's for the DAC. Let's go back to the spreadsheet, 27255. So again, here's the spreadsheet for the DAC, channel 1, and you can see the offset 27255. I think you get my drift now. Pretty simple. So once we've checked and double checked that we've transferred the data in the spreadsheet into here, obviously we need to make sure it's correct, double check it. We need to save this document, and I'll just remind you of where this document is. So we go back to our mutable development environment, Eurorack modules and stages. If we look down there, it's settings CC file. So let's just go back to the spreadsheet for a moment and the DAC calibration. When I said subject the module to -1 volts and 2 volts, I think I implied that you actually get a voltage source, set it to -1 volt, do that, and then get a voltage source and put 2 volts on the inputs. You don't have to do this with the factory test routine for the DAC. what you need to do is to rotate the top potentiometer on channel 1, so that's the one far left, rotate it fully anti-clockwise, and it does the -1 volts automatically for you. So in that position, the target value is -1. I achieved 0.9. Target value 2, and I achieved 2. So for the first column there, under -1, you rotate that first potentiometer at the top, not the slider, the rotary potentiometer, fully counterclockwise, do those. And then to do the second part of the test for the 2-volt column, rotate that potentiometer fully clockwise, and then do the same thing again. With the ADC, we actually need to bring an external voltage source of -1 volts and 2 volts and apply those to the CV inputs to create that table. Just one more thing of note, those values, their actual scale and actual offset, do those numbers look familiar? They are the numbers in the initial data set for the values for scale and offset for the DAC in settings HH when we initially flash the microcontroller. Underneath it you'll see those numbers there, and they should look familiar as well. Clearly, when we do our calculation, we need to make sure that those figures are correct and those figures are correct. Otherwise, when we come to calculate the offset and scale, they're not going to be correct, because these numbers are actually using the calculations in the spreadsheet to calculate the correct scale and offset for the DAC and ADC. So now we're going to check the module's calibration. So there's the final product. So what I've done is put each channel into the non-flashing orange mode. Now in this mode you can do something called sample and hold. So what I'm doing, I'm feeding a CV voltage into there where that yellow crocodile clip is connected, and I've got that crocodile clip connected to my multimeter, and it's reading 1.0045, so that's 5 millivolts on the input. So with the slider fully down, I should be able to move that crocodile clip to the output and read roughly the same voltage if the module's calibrated correctly. So now it's on the output. We come down to the meter, and as you can see, that the channel is calibrated to within a millivolt, so that's plenty good enough for, let's say, CV data, which is playing notes in a scale. So I'm quite happy with that one. Let's move the jacks over to the next one. So I'm going to use the same voltage source into the second channel, move it to the second channel, and again it's within a few millivolts, so I'm happy with that one. Next channel, it's within 2 or 3 millivolts, happy with that. Let's go back to see if this has moved at all. So I'm now going back to the input. Yeah, it is. It's slightly moved up. So again, it's within millivolts. So it's currently 1.6 millivolts. Let's move that to channel 4, and then the output for channel 4. So it's slightly drifting upwards, but 8 millivolt. Let's just go to this one quickly. That should roughly be about the same. So that's there. Yeah, and it's tracking really, really well. go to the 5th channel, take the reading 1.06 and to the output. Yeah, that one's moved a bit. Floating between 6 and 7 millivolts at the end. So that's the worst one that will come to. That's 4 millivolts out. Let's move to the last channel. And the input is so that's within 3 millivolts. So across the module it's slightly better at channel 1, slightly getting worse this way, but in terms of playing musical notes using 1 volt per octave scale, I'm quite happy with that. Winner winner chicken dinner. So we're on the final test for today before we start actually using this in anger to create some music. So as a final test, I've set the different channels like that. So I've got channels 2 to 6 on orange, but I've pressed them both switches simultaneously, which means that's the loop. So that's going to do a sequence of channels 2, 3, 4, 5, 6, and the voltages output will be set by the sliders. Channel 1 is a flashing green, so that's just a free running LFO, and I've got that knob on channel 1 set to about middle for diddle, so that's going to be outputting a sine wave. So the output of that, the sine wave, is actually going to go into the CV input of 2, 3, 4. So it'll play a note, and when this note plays, its voltage will be altered by that LFO. So let's turn it on and see what happens. And when that note's played by, manipulated by the LFO, I put some slew rate on that so it doesn't jump straight to it, it kind of slows down. So yeah, all is good. I think we need a hi-hat. That'll do for today. I think you get the drift. She's working and I'm an happy boy. So I think that now completes the project, but you never can tell what's going to come in the future. I do need to build a few more bits and bobs. If any of you would like to see any more, or maybe even talk about plats, rings or clouds, those builds, or any of the other stuff, some of this stuff in this rack is of my own sort of creation, so I should be able to offer some quite detailed insight into how I did that. But for now, that's it. Job done. Bye bye.